Hey everyone, this is Vincent. Last week I made a live stream about the FX map node within Substance 3D Designer, and everything went well. It was an introduction, and if you want to watch it, you have the link over there. But like the Murphy law says, there was something that I wanted to show that didn't go as I was expecting. Meaning that the FX map node is made to organize patterns in a way or another, and I wanted to organize them, to align them in one line, and then it goes to the second line, etc. And obviously I didn't find the right formula. Even if I show how it works, I stopped and say, okay, I'm going to do it later because I don't have the right formula in mind. So I'm going to show you right now how to do that, and within Substance Designer with the FX map. So let's do it. Here we are within Substance 3D Designer, and as you can see, I have created an FX map node that I set up to grayscale, and I edited it a bit to add in the quadrant a paraboloid shape. So now for this exercise, we are going to make it in two parts. The first one, I just want to align 10 by 10 patterns, this pattern, and then I want to repeat on each line. So I have like 10, then 10 on the second line, up to 100. There is an easy way to do that, which is with a floor node. We are going to see that. Then there is another way, which is a bit more complex, but which allows you to make it work with whatever number, which means like 1 by 1, 2 by 2, 3 by 3, 7 by 7, etc. So we are going to do this right now in two steps. The first one, for this one, I'm going to change the size of my pattern to 0.1, 0.1. This way I can align exactly 10. So now, if you have seen my live stream, you know that generally I make everything into color luminosity for good reason that I can explain later on. But at the moment, for the sake of speed, we are going to change the pattern offset and make some math directly in the pattern offset parameters. So I'm just clicking on it and doing empty function. And this is an offset with two values, two float values. So it's a float 2. If I create a float 2 like this, for example, I can set this as output, and now I can change the size, which is nice. And we say if we want to start trying, what we are going to do first is to make sure we have 10 patterns to play with. To do this, I'm going to go here, and I'm going to use an iterate node, which is this one. Oops, sorry, I'm going to remove this link, and I set this as root. So now I can define how many patterns I want. At the moment, you see that they are drawn one on top of the other. So let's put 10 at the moment, and go back to my quadrant, to my pattern offset function. And if I move this here, you see that I move the 10th pattern. So I have to find a way to make them unique somehow, each of them. To do this, I'm going to use a hard-coded variable, which is called $number. So this is a float. To call it, I'm going to use a get float, and you see that I have this $number. Any variable with a dollar in front of it is a hard-coded one, which means that it's dynamically generated by Substance 3D Designer. And this one, what it does, well, it allows you to reach an ID number which is assigned to each pattern iteration which is created in this FX map, which means that in that case, for example, we have 10 iterations of my pattern. The IDs will go from 0 to 9, and not that these are floats, so it's 0.0, 1.0, etc., etc. These are not integer. But the cool thing is now each pattern has a unique number, so we can take advantage of this to make some math and variation generated by this. For example, in my case, we want to align on X at the moment. I'm just going to create a vector float 2, which allows me to define for X and Y the values I want. So I'm going to create a float for Y like that, and then we are going, so I don't need this anymore, and I'm going to make some math. So let's define this as output node. I'm going to make a multiplication. As we want to place each pattern evenly on the y-axis, and we have 10, it means that they have to be at 0.1 units each of them. So I'm going to make a multiplication by 0.1. like this. So by 0, nothing happens. But now if I move this, you see that each pattern has a new offset value which is assigned to it. And as we say, 0.1 makes it perfect to tile. So that's really cool. Now what I want to define as well is I'd like this to start from the corner here. What you have to know is, once again, here we can control the offset, but the position is not 0, 0 here. The position is 0.5, 0.5, but the default offset, is 0, 0. So if I want to get here, it means that I have to remove 0.5 on X and Y. And that's what we're going to do. So I'm doing a subtraction, float 2, and I put 0.5, 0.5, and I set this as output node, and it won't work directly because you see that yes, okay, it moves, but now we have to take in account that the position, well, the offset is defined in the center of the pattern, so we have to remove half of the diameter of this pattern, which is 0.05. I can do it here. I'm going to put 0.45 and 0.45. Now you see that it works perfectly. Okay, so fine, we have made it for one line, which is great, but how do we do if we want multiple lines? We are going to see that by default it does not work. If I put 20, for example, you see that the patterns are drawn one on top of the other, but on the same line, which is normal because if you look at the graph, we don't change the Y value here. What we would like to do is to find a way, a mathematical way to say, okay, each time you are drawing 10 patterns, I want to add 0.1 to the y-axis. And we do that each 10 patterns are drawn. So how to do that? There are different ways, and the first one I want to show you, which works well in this example because it's 10 patterns, so it works well, is to use a floor node. So the floor node is this one, and what it does, this one, is that it takes a decimal value and it will remove any decimal. For example, if you have 1.1, it will give you 1. If you have 1.2, 1.3, 1.4, 1.99, it will return 1. Then if you go to 2.1, 2.3, etc., it will be 2, etc. It means that up to the 10th one, it will give 0. Then for the next 10 one, it will give 1, then 2, then 3, then 4. So, which is really interesting. That's exactly what we want, because we solve the first part, which is for each time you have drawn 10 patterns, return. Right now it's return 1, 2, 3, and we want to return 0.0, 0.1, 0.2, etc. So we just have to make a division by 10, which is like a multiplication by 0.1. So I'm going to duplicate this here, plug that here, and now if I plug this to Y, you see that it goes to the next line directly. And the great thing is that you can increase the number, and you see that it still works perfectly. Actually, there is, okay, I have an offset, I have to find Y. And maybe I have to make either -1 or +1 before to connect. Float. Okay, so let's see that. So now, okay, so I have, seems that it works. Okay, I just have to add 1 because as it starts at 0, it created an offset apparently. Let's check, double check, and it should be fine. Okay, so now it works. So 1, 2, 3, 4, 10, and we go to the line. So now it works up to 100. You see, that's fine. Now, how can we do to make it work with whatever number? To do this, we are going to have to adapt the number of pattern to also the number of to the size of each pattern as well. Now, what I want to do is to make it work for whatever number, meaning that if I want 1 by 1, 2 by 2, 3 by 3, etc. And it will require a bit more work and using a modulo node. I will explain what it does later on. The first thing I did is at the graph level, I have just created an integer parameter, which is controlling the iteration that I do have right now. So 1, 2, 3, 4, 5, 6, 7, 10, which is fine. But what I exactly want is the power of 2 of this number, meaning 1 power of 2, 2 power of 2, 3 power of 2, etc. To do this, I'm going to go here to iterate. And you see that I already created this to get to link the way it is right now. But as I say, I want to return the power of 2 of this number. So to do this, I'm just making a multiply. I multiply it by itself. Set this as output node, and now you see that the number is 1 power of 2, 1, then 2 power of 2 equal 4, then 9, then 16, 25, 36, etc. So this part is working well. But what I'd like to do is once again change the number here and the size as well. So if I do have 9 here, what I want to do is to have like 3 lines of 3. 2 things. First, we have to change the offset. We also have to change when it goes back to the line. And we also have to adapt the size so it fits everything. We are going to end with the size. If not, it will be hard to work because they are going to get all overlapped if I change the size right now. This will be a bit of browsing on my side at the same time. So at some time you may see the camera, the video accelerating. It means that I'm just looking for solutions. The first thing I'm going to do is going here, and this is my current offset. And we want to focus on 2 parts. So the first one is how to adapt the size. So once again, this time we have to take in account this number. So I'm going to call it now. It's an integer. So get integer. I'm going to find it. It's called pattern line number. And I'm going to convert it to float to do the math. Let's do it. I'm going to do with 2 at the moment, so we see. So the idea right now is at least to have 2 on the same line. So we should be able to divide by this number, taking this size, which is 1, and divide it by this number. So let's use a float, 1, and let's divide by this number. This is for the x value. And I'm going to return that here. It does, let me check, play with that, and you see that it does not work the way I want. At least it goes back to the line, but this is a bit messy. So at the moment, I'm going to isolate the y, stabilize it, so we just focus on y. So it means that my pattern number, it starts at 0 here. And I have to take in account also the dollar number that we do have here. So I may have to do the multiplication here and here. Okay, so it seems to be better. What I'm going to remove as well is the offset that we put at the end to start from the center. So now on the x-axis, it seems fine. So I took the dollar number and I multiplied the offset by 1. So the full length of x divided by the amount of pattern we do have on this line. So divided by 2. So in that case, it will be 0.33. If I do by 2, it's interesting to them. We may want to make an offset. We'll see, fix the final offset later on, but at least it works. Now that we do have that, we want, you see that they goes one on top of the other. In that case, for example, there is 9 patterns, but they are drawn one on top of the other. But the good thing is that at least it works on one line. It's the spreading is the right one. So let's work on Y. And here, that's where I would need the modulo. So the modulo is the rest of the division, which means that, for example, if you have 7 divided by 3, the result is 2, yet you have a modulo of 1, which is the rest of the division. And the great thing with modulo, you may say, okay, why would I use that? Because it has a great property, which is it acts like a repeating loop, meaning, for example, the modulo of 4 is always 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3. Whatever number you are going to take, it will respect this loop. And it's really interesting for us because here we want to take in account this number to know when to change the line. So using this number with a modulo will help getting to the next line. Let's do this. So first I'm going to delete all of this. And I don't need that at the moment. Okay, so now just found the solution. So once again, for the y-axis, now what we want to do is to make sure that, for example, in that case, let's put at 3, we say, okay, once you draw the first 3 on a line, then after these 3 ones, add an offset, which will be a third of the size to the 3 next one. So we need 2 stuff. First, the modulo. And once again, it will be a modulo which will be dynamically changed depending on this pattern line number, like this, for sure, and will be a flooring. Because if, once again, what we want is, while you take this one, you repeat the same value. So I have once again to floor the value here. Here we have like the number with the specific. In that case, we see that it's the offset is 0, then it's 0.3, then 0.6. So I'm going to create a floor here. So for the 3 first one, it always returns 0. And then for the 3 next one, it will return 1. And then for the 3 next one, it will return 2. So here I'm just making sure that it's the 2 floats which is connected here as well. So now what it will return 0, 0, 0, then 1, 1, 1, then 2, 2, 2, which is interesting. But I want to fit that to make sure. So 0, 0, 0 is fine. But when it's 1, it has to be 0.33 in that case of 3, then 0.25, etc. So it means that if we take this number, 1 divided by the pattern line number, we have the right number. So I'm going to make here a multiplication by that. I take this, multiply, and let's multiply by this. Maybe I will cross this with X, and now it works. So as you can see, it worked with odd number, but even number, we had this problem that we'd like to get an offset so it's in instead of on the border like this. It means that I do have to create a condition, like if it's an even number, then apply a specific offset. To do this, first, how can we recognize an even number? Well, it's kind of easy. If we use the modulo, once again, we can take this number here, and if we do a modulo 2, so I will put a float, and I will put 2. Well, if it's an even number, the result for modulo 2 will always be 0. So we can use this property to create a condition. So I'm going to use an if else node. So how does it work? So you put the condition here. If it's positive, you put this one, else you put this one. Here I would say, okay, if modulo 2 is equal to 0, this is my condition. I'm going to just hide it. I'm docking it with the D key, and I will say if it's equal to the 0, then this will be for even number, else we can plug this one. So now it does not work for even number because we didn't define any condition. I'm going to make a bit of space, and what I'm going to do is to use this number here, because we have what we want to do is, for example, if we have like number 2, we want to have half of the distance between both, and the distance is here, this one, this is the distance here. So I'm going to take this here, I'm going to make a multiplication like this, multiply by 0.5 to get half of the distance, and now I'm going to add this to the current position, which is this one. So I'm just going to make an addition. You will notice that if I do the addition here, I do need a float 2, so I'm going to use this number in a vector float 2, sorry, like this. I want the offset to be horizontal and vertical, and I'm just adding this. And now if I put if the condition is met, you see that it works perfectly, and it means that now I can change the number up to 100, and you will get your grid. Now the last part we want to do is to adapt the size of the pattern to fill everything at any number. We're going to do that here, of course. So the first thing I'm going to do is, right now it's 0.1, so I'm going to create a float 2. Let's put 0.1, maybe 0.2, 0.2, even if it's temporary. So it's just to see if we plug it right. And if you remind, to output this value, what we do have to create is a set node to create a variable. I'm going to call it size param, Ctrl C, And here I'm going to make a sequence again. How it works, we do plug the already existing sequence node, which is linked to our main value for this parameter. And then I'm going to plug that here. And make a bit of organization here so it looks a bit better. Like that, I put this as output, and now I just have to go to my pattern here, pattern size. Here I have the value. I'm going to create an empty function, get float 2, passing the name, and right click, set as output node. And you see that now they are 0.2, 0.2. What we do want is to adapt the size depending on this number. So let's go back here. You see that, yes, it's well plugged. And to do this, well, it's kind of easy. We already have the number here. We have to divide once again by this number. So if I plug that here, I will create a vector, float 2, taking this value and using that. You see that now the size will adapt depending on the number you do have, which is what we want. And that's it for this video. I hope it has been useful. It has been a bit longer than what I was expecting at first, but it allowed me to show you some more techniques to play with your patterns within a fixed map node. This is obviously something that you can do with a tile sampler or tile generator, for example, but I did this for the sake of discovering how you can use the FX map node. So I hope you will create your own patterns and new noise textures tools with it. Thanks again for watching this video, and we see each other in the next one. Bye bye.